What would happen if Earth was hit by an asteroid? Would it shatter in the Earth's atmosphere? Would it wipe out an entire city? If not, how long would humanity have to escape? How big would the impact be? Could we survive? To answer those questions, we have to understand what really happens when a giant space rock meets our world. It's about how they hit and what they're made of. And depending on those factors, the outcome could be anything from a harmless light show to the kind of disaster that rewrites history. In 2018, astronomers spotted an asteroid designated GE3 passing surprisingly close to Earth. Alarmingly, the approximate size of a football field. For a brief moment, it looked like destiny had lined up our paths with terrifying precision. Then, with a small but crucial shift in trajectory, it curved away and continued toward the sun. Harmless, a near miss, but it leaves us with a chilling question. What if it didn't miss? What if it kept coming straight towards us? This asteroid harmlessly followed its orbit past Earth, but it highlights a bigger concern. What if a future asteroid's path wasn't a near miss, but a direct hit? We tend to think of asteroid impacts as rare doomsday events, but the reality is that Earth is hit by asteroids constantly. Our planet is peppered with cosmic debris every single day. Around 100 tons of dust and tiny grains fall through the atmosphere without anyone noticing. Slightly larger meteoroids, roughly the size of a car, enter our skies about once a year. They usually burn up high above us, disintegrating in the atmosphere before they ever get the chance to reach the ground. The truly catastrophic giants, the 10-kilometer monsters like the one that ended the reign of the dinosaurs, are incredibly rare. The good news is that these colossal impactors are estimated to hit once every 100 million years, and the last one that hit was 66 million years ago. So the likelihood of one striking Earth within our lifetime is incredibly low. However, the ones that require our attention are the mid-sized objects, roughly the length of a football field, just like the 2018 GE3 asteroid. These are large enough to punch through the atmosphere and reach the surface. And the scary part is that they may hit the Earth roughly once every couple of thousand years. These monsters are capable of wiping out an entire city. They will flatten or vaporize everything in the immediate impact zone. Severe shock waves could knock down structures tens of kilometers away. So imagine for a moment that one of these objects was on a direct collision course with Earth tonight. What would you do? To understand the threat, we must understand the object. What is an asteroid? Asteroids are ancient relics left over from the formation of the solar system, fragments of failed planets, billions of years old. Some are stony and brittle, others are metallic, dense enough to survive the furnace of atmospheric entry. A few are carbon-rich, containing organic ingredients that could have seeded life itself. Most orbit harmlessly between Mars and Jupiter in the asteroid belt, but a select few have chaotic paths. They wander. They cross orbits and flirt with disaster. Earth has been struck repeatedly over its history. Some collisions were harmless, meteors burning up in a flash across the night sky. Others scarred continents, boiled oceans, and reset evolution. 66 million years ago, one of them, roughly 10 kilometers wide, struck and ended the age of the dinosaurs. Not because of the impact alone, but because of what followed. Firestorms, earthquakes, and years of winter. The rock didn't just kill the dinosaurs, it made way for us as humans. So how do we know if an asteroid is heading straight for us? Asteroids don't announce themselves. They don't glow like stars or leave trails like comets. Most of them are dark, cold rocks drifting through the solar system, almost invisible against the black. So how do we even find them? The answer begins with a network of powerful telescopes that sweep the sky night after night, constantly searching for anything that moves. These telescopes capture images of the same patch of sky minutes apart. In each frame, the stars remain fixed, but a nearby asteroid appears as a tiny speck that shifts position. Software compares these images, flags anything moving, and alerts astronomers to a possible new object. From there, scientists calculate its orbit, measuring brightness, speed, and trajectory to understand whether it's harmless or something we need to pay attention to. Once an asteroid is detected, observatories around the world collaborate like cosmic detectives, More telescopes track it, more data is gathered, and the path becomes clearer with each observation. If the orbit shows no threat, it's cataloged and monitored occasionally. But if the numbers suggest even a small chance of crossing Earth's path, it becomes a priority target for continuous observation. The faster we detect it, the more time we have to prepare, or even deflect it. And this is why surveys like NASA's NEOWISE, the Pan-STARRS telescopes, and the Catalina Sky Survey are so important. They're our early warning system, our eyes in the dark. Because the truth is, space is filled with wandering rocks, and the only way to avoid a surprise is to keep looking up. So what would happen if an asteroid actually hit Earth? If an asteroid similar in size to 2018 GE3 were to enter our atmosphere, the first sign wouldn't be a slow descent. It would be a sudden blaze of light tearing across the sky. Traveling at tens of thousands of miles per hour, it would superheat the air in front of it, creating a fireball brighter than the sun. Within seconds, a deafening shockwave would follow, rattling windows and triggering car alarms long before it ever reached the ground. If the asteroid exploded in the atmosphere, like the Chelyabinsk event in 2013, it could still release energy equivalent to multiple nuclear bombs, powerful enough to shatter glass across a city and injure thousands from shockwave alone. But if it survived atmospheric entry and reached the surface, the consequences would escalate dramatically. The impact would create an explosive blast, carving out a crater and releasing energy powerful enough to level buildings across several kilometers. In a dense urban area, skyscrapers would crumble, infrastructure would collapse, and the thermal radiation could ignite fires across entire city blocks in moments. The area closest to the impact zone would be obliterated instantly with a devastating flash of heat, shock, and debris. Beyond that, the shock wave would roll outward like a wall of force, toppling structures and leaving streets unrecognizable. The effects wouldn't end at ground zero. Emergency services would be overwhelmed, power grids could fail, and communication networks might collapse under the sudden surge of damage. If the asteroid struck water instead of land, the threat would shift. Massive waves could form, racing toward coastlines as destructive tsunamis capable of flooding harbors, destroying coastal towns and sweeping miles inland. Either way, a GE3-type asteroid wouldn't destroy the world, but it could destroy a city, and the surrounding region would feel the impact for years to come. Heat is also another major factor. The impact flash can ignite forests instantly, and thermal radiation can burn skin or start fires even miles away from ground zero. In large impacts, this burning phase can engulf entire regions, turning cities into firestorms. Larger asteroids bring climate change into the equation. Dust and aerosols thrown into the upper atmosphere can reflect sunlight back into space, cooling the planet. This is what scientists call an impact winter. Temperatures drop, crops fail, and food becomes scarce. Even a mid-sized asteroid wouldn't trigger a full extinction event, but it could disrupt global agriculture, trade, and civilization. The world's attention would shift from technology and politics to farming, survival, and rebuilding. The scale of destruction depends entirely on size. A small asteroid might explode harmlessly in the atmosphere, creating a flash in the sky. A medium one could destroy a city. A large one could disrupt civilization. A giant could reshape life on Earth for millions of years. The asteroid doesn't choose, physics does. It's up to us to detect, prepare, and if necessary, intervene. So what would happen if you were directly hit by an actual asteroid? If you were unfortunate enough to be standing directly in the path of an asteroid, even a small one, your body wouldn't stand a chance. The speeds involved are astronomical. Most asteroids travel through the atmosphere at 20 to 70 kilometers per second. To put things into perspective, that's faster than a bullet and faster than anything the human body could withstand. Upon impact, there would be no moment of pain or realization. At that velocity, the asteroid carries so much kinetic energy that the human body would be instantly vaporized or torn apart, depending on the asteroid's size. We aren't talking about being knocked over. We're talking about complete obliteration in a fraction of a second. The heat generated during atmospheric entry alone could ignite clothing and skin before it even makes contact. If the asteroid were large enough to reach the ground intact, the blast wave alone, even without a direct hit, could kill you. The intense pressure would crush organs, rupture eardrums, and throw the body like a rag doll at lethal speeds. Anyone close enough to witness the impact up close would be in the middle of a fireball and violent air displacement. Death would be instant. Even a tiny pebble-sized meteor traveling at cosmic speed would behave like a high-velocity bullet, punching through the body with explosive force. Something the size of a fist could hit like a bomb, tearing flesh and bone apart. You would not be sent flying, you would simply cease to exist. The terrifying part is how fast it would happen. No pain, no warning, just a flash of heat, a shockwave of energy, and then nothing. At cosmic speeds, even the smallest fragment becomes a weapon powerful enough to end a life in the blink of an eye. And that's only the smallest scenario. Is it possible that a destructive asteroid could hit Earth within our lifetime? The answer is alarmingly yes. It is scientifically possible that an asteroid with devastating effects could hit Earth in our lifetime, but not necessarily likely. We've mapped many space rocks, yet not all, and it only takes one we don't see coming to change history forever. But here's the reassuring part. Asteroids the size of GE3 only tend to strike Earth about once every few thousand years, and the colossal extinction-level giants that ended the age of the dinosaurs are estimated to appear only once every 100 million years. So for now, we're relatively safe. As long as we keep watching the skies, tracking, and identifying any threats long before they ever get close. So how could Earth prepare or prevent such a disaster? Could we stop it? If scientists discovered a medium-sized asteroid heading toward Earth with enough time to act, preparation would become a global priority. If there was enough time, ideally years rather than months, the mission would shift from response to prevention. Space agencies could launch a kinetic impactor, similar to NASA's DART mission, to ram the asteroid and nudge its trajectory by a fraction. It wouldn't need to move much. A tiny change today could prevent catastrophe years later. Other methods exist too. A gravity tractor spacecraft that slowly pulls the asteroid off course, or in extreme cases, a controlled nuclear detonation near its surface to alter its path without shattering it into smaller, dangerous fragments. These techniques aren't just theory, they're being researched, tested, and refined right now. But what happens if deflection wasn't possible, or the discovery was too late? Earth would need to prepare for impact. Evacuation plans would be activated to move people away from the projected impact zone. Infrastructure could be shut down in advance to reduce fire and gas explosions. Emergency shelters and underground bunkers would protect those who cannot evacuate. Food reserves could be stockpiled, hospitals reinforced, and communication systems hardened so that society can recover quickly after impact. For coastal targets, evacuations would stretch far inland to avoid potential tsunamis. Our survival would simply depend on organization, planning, and cooperation. We cannot stop every rock in space today, but we can prepare for one. Early detection and a willingness to act could mean the difference between disaster and resilience. The more we watch the sky, the safer we are. Right now, thousands of asteroids large enough to destroy cities remain undiscovered. Some will pass harmlessly, some will not. The good news is that we are learning. The DART mission proved we can change an asteroid's path. Telescopes are improving. Early detection is getting better every year. If we find a threat decades before impact, we stand a fighting chance. Our survival depends on curiosity, technology, and the will to act before it's too late. Because the real danger isn't the giant dinosaur killer we already know about. It's the one we've never seen. The one discovered too late. The one that won't give us years of warning, but maybe days. So ask yourself this: if Earth had only 1 week left, what would you do? Would you chase the last sunrise or the last memory? Would you run for survival, try to fight fate, or accept it with open arms? Because an asteroid strike isn't just a scientific scenario. It's a mirror held up to humanity. It forces us to confront what truly matters: our fears, our priorities, what and who we would save when everything else falls away. If this journey through possibility made you think differently about our place in the universe, then make sure you like this video, and subscribe to join the community. We explore the events that shape the past, threaten the present, and could determine the future of humanity itself. And tell us in the comments, if an asteroid was coming, what would be your final wish for humanity? Thanks for watching, Orbit Crew. We'll see you on the next mission.